With version 18, we have added the route-based VPN method into the framework of IPsec VPN functionality. Route-based VPN creates a virtual tunnel interface, or VTI, that logically represents the VPN tunnel, and any traffic that is routed towards this interface is encrypted and sent across the tunnel. Static, dynamic, and the new SD-WAN policy-based routing can be used to route the traffic via the VTI. The prerequisite is that the Sophos XG must be running SFOS version 18 or above. The following is the diagram we are using as an example to configure a route-based IPsec VPN. XG devices are deployed as gateways in the head office and branch office locations. In the head office network, port 2 is the internet-facing WAN interface configured with the IP address 192.168.0.77. Port 1 is the LAN interface configured with the IP address 172.16.1.13, and its LAN network resources are in the 172.16.1.0/24 subnet range. In the branch office network, port 2 is the internet-facing WAN interface configured with the IP address 192.168.0.70. Port 1 is the LAN interface configured with the IP address 192.168.1.75, and its LAN network resources are in the 192.168.1.0/24 subnet range. As per the customer's requirement, the branch office LAN network should be able to connect to the head office LAN network resources via the IPsec tunnel, and the traffic flow should be bidirectional. The branch office XG acts as the initiator of the VPN tunnel, and the head office XG device as the responder. So let us see the steps to configure this scenario on XG version 18. So first, we go through the configuration steps to be done on the head office XG. Navigate to Configure VPN IPsec Connections and click on the Add button. Enter an appropriate name for the tunnel. Enable the Activate on Save checkbox so that the tunnel gets activated automatically as soon as the configuration is saved. Select the connection type as tunnel interface and gateway type as respond only. Then select the required VPN policy. In this example, we are using the inbuilt IKE-v2 policy. Select the authentication type as pre-shared key and enter the pre-shared key. Now, under the local gateway section, select the listening interface as WAN port 2. Under remote gateway, enter the WAN IP address of the branch office XG device. The local and remote subnet fields are grayed out because it is a route-based VPN. Click on the Save button, and then we can see the VPN connection configured and activated successfully. Now navigate to Configure Network Interfaces, and we can see an xfrm interface created on the WAN interface of the XG device. This is the virtual tunnel interface created for the IPsec VPN connection, and once we click on it, we can assign an IP address to it. The next step is to create firewall rules so that the branch office LAN network can allow the head office LAN network traffic and vice versa. So first, we navigate to Protect Rules and Policies Firewall Rules, and then click on the Add Firewall Rule button. Enter an appropriate name, select the rule position and appropriate group, logging option enabled, and then select Source Zone as VPN. For the source network, we can create a new IP host object with the IP address of 192.168.1.0 with a subnet mask of /24. Select the destination zone as LAN, and for the destination networks, we can create another IP host network object with the IP address of 172.16.1.0 and a subnet mask of /24. Keep the services as any and then click on the Save button. Similarly, we create a rule for outgoing traffic by clicking on the Add Firewall Rule button. Enter an appropriate name, select the rule position and appropriate group, logging option enabled, and then select the source zone as LAN. For the source network, we select the IP host object 172.16.1.0. Select the destination zone as VPN, and for the destination networks, we select the IP host object 192.168.1.0. Keep the services as any, and then click on the Save button. We can route the traffic via XFRM tunnel interfaces using either static routing, dynamic routing, or SD-WAN policy routing. In this video, we will cover the static routing and SD-WAN policy routing methods for the VPN tunnel traffic. So, to route the traffic via a static route, we navigate to Routing, Static Routing, and click on the Add button. Enter the destination IP as 192.168.1.0 with a subnet mask of /24. Select the interface as XFRM tunnel interface, and click on the Save button. Now, with version 18, instead of static routes, we can also use the new SD-WAN policy routing method to route the traffic via XFRM tunnel interfaces with more granular options, and this is best used in cases of VPN to MPLS failover and failback scenarios. So to route the traffic via policy route, we navigate to Routing, SD-WAN Policy Routing, and click on the Add button. Enter an appropriate name, select Incoming Interface as the LAN port, select the source network as 172.16.1.0 IP host object, the destination network as the 192.168.1.0 IP host object. Then, in the primary gateway option, we can create a new gateway on the XFRM tunnel interface, with the health check monitoring option as ping for the remote XFRM IP address 4.4.4.4, and then click on Save. Additionally, if you have MPLS link connectivity to the branch office, you can create a gateway on the MPLS port and select it as the backup gateway, so that the traffic fails over from VPN to the MPLS link whenever the VPN tunnel goes down, and fails back to the VPN connection once the tunnel is re-established. In this example, we will keep the backup gateway as None and save the policy. Navigate to Administration Device Access and enable the Ping option on the VPN zone to make sure that the XFRM tunnel interface IP is reachable via the ping method. Now, from the command line console, make sure that the SD-WAN policy routing is enabled for the reply traffic by executing this command. If it is turned off, then you can enable it by executing this command. So this now completes the configuration on the head office XG device. On the branch office XG device, we create a similar route-based VPN tunnel that has the same IKE v2 VPN policy and the same pre-shared key, the listening interface configured as the WAN interface port 2, and the remote gateway address as the WAN IP of the head office XG device. Once the VPN tunnel is connected, we navigate to Configure Network Interfaces and assign the IP address to the newly created XFRM tunnel interface. To allow the traffic, we will navigate to Protect Rules and Policies, Firewall Rules, and create two firewall rules, one for outbound and one for the inbound traffic flow with the branch office and head office LAN network subnets. Now, to route the traffic via static route, we can navigate to Routing, Static Routing, and create a static route having the destination IP as the 172.16.1.0 network with the XFRM selected for the outbound interface. As discussed earlier, if the routing needs to be done via the new SD-WAN policy routing, then we can delete the static routes and then navigate to Routing, SD-WAN Policy Routing, and create a policy having the incoming interface as the LAN port, the source network as 192.168.1.0 IP network, and the destination network as the 172.16.1.0 network. Then, in the primary gateway section, we create a new gateway on the XFRM tunnel interface with health check monitoring options set as ping for the remote XFRM IP of 3.3.3.3. And select it as the primary gateway. Keep the backup gateway as none and save the policy. Navigate to Administration Device Access and enable the ping option on the VPN zone to make sure that the XFRM tunnel interface IP is reachable via the ping method. From the command line console, we will ensure that the SD-WAN policy routing is enabled for the reply traffic. And this completes the configuration on the branch office XG device. Some of the caveats and additional information associated with route-based VPN in version 18 are: if the VPN traffic hits the default masquerade NAT policy, then the traffic gets dropped. So to fix this, you can add an explicit NAT policy for the associated VPN traffic. Even though it is not recommended generally, but if you configure IPsec connectivity between policy-based VPN and route-based VPN, and face some issues, then make sure that the route-based VPN is kept as a responder to achieve positive results. Deleting the route-based VPN connections deletes the associated XFRM tunnel interface and its dependent configurations. Unbinding the WAN interface will also delete the corresponding XFRM tunnel interface and the IPsec VPN connection. Here are some workflow differences between policy-based VPNs and route-based VPNs. Auto-creation of firewall rules cannot be done for the route-based type of VPN, as the networks are added dynamically. In the scenarios having the same internal LAN subnet range at both the head office and branch office side, the VPN NAT overlap needs to be achieved using global NAT rules. Now let's look at some features not supported as of today, but will be addressed in future release. GRE tunnels cannot be created on the XFRM interface. You are unable to add a static multicast route on the XFRM interface. And DHCP relay over XFRM. Finally, let us see some of the troubleshooting steps to identify the traffic flow for the route-based VPN connection. Considering the network diagram as the example, and a computer having the IP address 192.168.1.71 located in the branch office and trying to ping the web server located in the head office. So, to check the traffic flow from the branch office XG device, we navigate to Diagnostics Packet Capture and click on the Configure button. Enter the BPF string as web server IP address and proto ICMP, and click on the Save button. Enable the toggle switch, and we can see the ICMP traffic going out via XFRM interface. Similarly, if we open the log viewer, select the firewall module, and search for the web server IP address, we can see the ICMP traffic passing through the XFRM interface of the device with the associated firewall rule ID. Once we click on the rule ID, it will automatically open the firewall rule in the main web UI page, and accordingly the administrator can do further investigation if required. In this way, route-based IPsec VPN in Sophos XG version 18 can be used for connectivity in head office, branch office scenarios, and can also be used to establish the VPN connection with the other vendors supporting route-based VPN methods. We hope you enjoyed this video and thank you for watching.